space, and all the properties has been defined. So as you recall that we started with the vector space and we defined the properties, and then we talked about the first is numeric field, then vector space, then you have the metric space. We talked about distance between two vectors, and then we start talking about the non-linear space, which talks about the length of the vector, and then once the length and distance are defined, then we actually have angle between two vectors, which are the typical characteristics for the inner product space. And finally we said that complete inner product space is nothing but Hilbert space. Later on I went for giving the pictorial diagram and state the properties, and we talked about the metric space, and next we will go into so now it assumes all properties are valid. In that case, it is possible to have the properties in a proper format, which is the non-linear space. We have non-linear space which talks about length of the vector. Which talks about the length of the vector. So we will define the non-linear space, the properties in one, and if any quantity is there in a vector, we define the norm like this. So double vertical line. This talks about length of the vector. In a very if you are in mathematics stream, they talk about different kind of norm, and many of the books you see this type of norm. They call two norm or infinity norm. Okay. But norm, actually, I will not go in this kind of details because we are all engineers and we have to, of course we will do mathematics, but we have to see, you have to feel the mathematics. If you don't feel, you cannot appreciate better. So we will see how we can see the norm, this quantity, in a real picture. So first property is norm is greater than or equal to 0. Let's look at in our coordinate geometry how the norm looks like. There is a point, and this has say u1, u2, the components of u vector, and the norm, what actually for how it is when you look at, we'll define norm from metric space. Metric space d u bar v bar is defined as summation ui minus vi whole square root. Do you agree or not? Yes? Why? From coordinate geometry. This is the u vector. This is v vector. This is du or v bar. Here the u vector you denote as u1, u2, and v vector you denote as v1, v2. That means coordinate of this point is u1, u2. Coordinate of this point is v1, v2. The distance between 2 points, the coordinates are u1, u2 and v1, v2 is denoted by, from the coordinate geometry, is square root of u1 minus v1 whole square plus u2 minus v2 whole square. Is it correct? Does it make sense? It is coming from the 10 plus 2 coordinate geometry. The coordinate of the point is u1, u2. The coordinate of this point is v1, v2. v1, v2. And for the coordinate geometry, you have summation ui minus vi whole square to the power half. Does it make sense? Yes or no? Any confusion? Okay. Now, from the metric space, the length can be defined if you put here instead of v u bar. That means you are having a distance between this to this way actually 0, right? Because u minus u is actually equals to 0, right? It is actually 0. So now from the distance, how we can actually talk about how we can get the length of a vector? Any idea? If you put u is u, you will get 0. Doesn't make any sense. How to get length from the metric space? Which two vectors? What is the distance between two vectors? Which will give length? 0. Yes. Who said? 0. Correct. So this on vector I have this is the vector, it's called non-vector, zero vector. And this vector distance is this one, right? For example, I have a point here and I have a point here. Okay? So this is the vector for this position vector, and this is the vector position vector of this. You can put it here. Okay. And the distance is, this is your DUV, this is U1, this is V1. This is DUV1, right? So now, if this point goes to here, then this and this will merge. Okay? And this is nothing but the length of the vector V1, right? So, if this point tending to 0, that means this will become a null vector. U vector will become a null vector, or V vector will become a null vector. So, in that case, you can actually have D V1 V1, or sorry, D 0 V1, which is equals to summation Vi square I equals to 1. Right? Correct? With this vector, so distance of metric space gives the idea of the non-linear space. So that means what? In precise, it is the length of the vector, which is, this is the coordinate is u1 comma u2, which is u1 here, u2 here, the square, and this length is the square root of u1 square plus u2 square. And this we are getting from the metric space. This we are getting from metric space. Right? So, the non-linear space, so one can actually define norm as summation ui square whole to the power of, and which also can be defined from the metric space. You can say zero vector. So metric space you can define the norm. But clear? Okay. So N2, the properties. Now we have an idea. What is the, so that means to define the length we need to have metric space. To define the metric space we need to have vector space. If you don't have vectors, you cannot have distance between two vectors. If the distance is defined, you can define the length by this expression. You can see that. This point, if it comes, then this distance will become the length of the vector. Okay? And that's what non-linear space is, the subspace of the metric space in the set theory. The set theory, therefore the set theory also, we can see first come vector space, then come metric space, and then come non-linear space. Unless distance is defined, this definition we cannot argue. That is the we can actually have argument. Then two. Now if you see that this is equals to 0 if and only if u is a null vector. If and only if u is a null vector. N3, which is norm of alpha u, which is norm of alpha, norm of u. How to prove it? How to prove it? Mathematically we can prove pictorially also. Mathematically can prove from the property. So basically what we can do, left hand side, we can write summation alpha ui square whole to the power of, right? I equals to 1 to n, and alpha square will come out. And we have summation ui square, and we have alpha. Am I correct? So is it. We can do it pictorially. Okay? So if you increase the length of that, the vector, of course, that will be multiplied by alpha on, so that you can actually try it at home. Next is N4, which is norm u plus v equals to less than equals to norm of u plus norm of v. Norm of u plus v less than equals to norm of u plus norm of v. How to prove it? How to prove that one? Any idea? Any idea of norm of the last property? How to prove it? What is that actually? What is that? Let me draw the diagram. This is u bar. This is v bar. Okay. How to prove it? This length of u, this length of v. How to get u plus v? Am I correct? It's all everything coming from your 10 plus 2 physics. If you are clear in physics, 10 plus 2 physics and math, this math course is it. In the 10 plus 2 physics, what we have seen? Law of parallel law of vectors. P plus Q, right? So these are U plus V. What we are seeing is V, these are U, right? Okay? So you can see that this length is norm V, this is U, because this is a parallelogram, this side is to this side. So this is norm of, now you know that length of this vector is U. Because we have defined this, norm of V is this, and this norm of U plus V. So this norm means they are representing the three lengths of the triangle. The triangle is, so if it is OA, B, C. So your triangle is OBC triangle. OBC triangle, OB is norm of V, OC is norm of U, and BC is norm of U, and OC is norm of U plus V. And you can see that the one side length is less than equals to other side. Yeah, that's what we have already seen in the matrix. So this is the way we can actually define. And now I will ask you, this is by your home task, mathematically, it is summation I equals to 1 to n ui plus vi whole square whole to the power half. Am I correct? Okay. So what are you getting? Square root of summation ui square plus summation vi square plus 2 summation ui vi. Am I correct? So now norm of u plus norm of v is what? Which is equals to summation ui square plus summation vi square to the power half. So is it possible to prove this quantity is bigger than this? That's what I was asking for the proof. Is it possible? What did I do correct, right? How to prove it? How to prove it? Is it correct, right? Whatever I wrote, any confusion here? It's all one definition. Norm of u is what? Summation of u square to the power half. Norm of u plus v is, so u1 is what? u1, u2 up to un. v1 is v1, v2 up to vn. u1 plus v1 is u1 plus v1, u2 plus v2, un plus vn. That's why I wrote. Everything is coming what? It's pretty fundamental level. And now if you take if you expand it, the square root of us square plus v square 2 summation ui vi. And I am saying that this is less than equals to summation of ui square to the power half plus summation of vi square to the power half. How to prove it? Try it out. I want to see it. Maybe next class somebody will give me the proof. And that could be one of the possible exam questions. Yes, any doubts? Any confusion here? Okay. So you have proved it from the diagram, but I want to see the proof from the mathematical aspect. How to prove it mathematically? Pardon? Inner product we don't know so far. So far we don't know inner product. So we have to do it from here. We don't know inner product so far. Right? Okay? So next we will actually, before going to inner product space, I want to see the application. I want to see the application of this. Ax equals to b. We always try to find solution of this. Sometimes we solve this by analytical. Sometimes we solve by numerical. Analytical, you know the scheme, right? Cramer's rule. You solve by Cramer's rule. numerical we solve by Gauss elimination. We have seen the Gauss-Jacobi, Gauss-Jordan, so many family of those problems. We can do it later on, all the numerical stuff. So analytical, we get the solution which is called as x exact. Numerical, x approx. Generally speaking, for the analytical case, we can always have x exact is strictly possible, but when you do numerical approx, it is approximated, we are assuming equals to, it may not be. That means there could be some difference. Okay, there could be some difference. So, in a vector space, you can have here this vector x exact, this is x approx. What is this? Distance between x exact and x approx. This one, which is the error vector. So, metric space has direct application to estimate the error vector, right? So that's the way we can see how these things actually apply for estimation for different mathematical perspective. So error is nothing but distance between x exact and x approx. So if you know the property of metric space, we can actually quantify the errors, right? Fonda is clear. Okay. So now we will be talking the next part, which is called as inner product space. What is inner product space? The first time you are hearing inner product space, earlier you have not heard this term, right? So, but if you look at your 10+2 physics, in that case we will see that inner product is already defined in 10+2, which is nothing but dot product between two vectors. So, this is coming from dot product. This is coming from dot product. Okay, so how do you define dot product? This is the P vector. This is a Q vector. This is angle, theta. So you say P vector dot Q vector is nothing but norm of P, norm of Q plus theta. I will replace P vector now as Q bar, where I define this as U1, U2, Un. Q vector I will say as V bar, which I define as V1, V2 up to Vn. Okay. So in that case, it will be U bar dot V bar, which is norm of U bar, norm of V bar plus theta. Is it okay, acceptable? This is a definition from physicist. From your physics book of 10+2, you could define this. Now a mathematician comes in picture. He says, I don't accept U dot V, this notation. So mathematics guy comes in picture. He defines the dot product by this, the notation. This is called as inner product. This is called as inner product. This is called as inner product, which is defined as. What is mathematician's definition? Any idea from your side? Mathematician will not define norm of U into norm of V cos theta. He has got something else. Because mathematician will not say P and Q. He will say VU and V bar. This is the way. So you have to define only with these quantities, no other cos theta will come in picture. Understood my question? When a physics guy define, we will say all those diagrams. Physics guys like picture. Mathematics guys only symbols. The difference between physics and mathematicians. Physics guys like picture, physics. What is moving? They want more picture. mathematics guys will keep saying, I don't understand picture, I only want symbol. The guy come, mathematicians come in picture, he says, what is cos theta? I don't want. This is my u and v. I want to define it this. What is the definition from the mathematician? Okay. Now, if it is the case, I want to, okay, you'll be guessing so many things. First of all, tell me, is it scalar or vector? Scalar quantity. A scalar quantity, if I ask you to reproduce in matrix, what will be the matrix size? 1 by 1, excellent. So U vector, what is the, how do you write? N row, 1 column. It is also n row, 1 column. N dimensional vector space. So how they will be used such that they will give 1 by 1? Yes. So V transpose U. No, it only U transpose V. Or you can also say V transpose U.
Yes.
Yeah, it makes sense. V transpose U 1 by N, and then so it is 1 by N. It is becoming 1 by 1. That's the way mathematicians define. Because mathematicians don't have other weapon. Mathematicians will not understand physics. Of course they understand. But for them, these are symbols. Okay? And the final thing, if you do that, it is coming as summation ui bi bar. Why I am saying that? Because these entries could be complex quantity also. These entries could be complex quantity also. So it could be summation ui vi bar. And in that case, my definition is V bar transpose U. So you can write this the new definition. It is V bar star U, which is nothing but summation ui vi bar. This V bar star means V bar transpose. And it happens, this is for the complex quantity. We took as complex conjugate. So assuming U and V, they are forming n-dimensional complex space. If it is real space, it is Rn. I am saying complex, more generalized. I am saying complex, more generalized. This definition is clear. This is giving 1 by 1, right? So you are multiplying this. So this will be coming as row, this as column. So this is V1, U1, then V2, U2, and then you take the bar, complex conjugate. So V1 bar U1, V2 bar U2, V3 bar U3, and up to it will go n. Is this definition clear to all of you? Yes or no? Now I am not happy here. This is not clear to me. This is clear to you, but I am not happy. This is not clear to me. You know why? This is guy coming and saying this is the definition. Mathematicians come and say this is the definition. Both have to be same, no? I am not getting it. This physicist guy, you also know that. My mathematics friend is giving this, but they are not coming saying, I cannot accept. Which is correct? Both have to be correct, and both have to be the same. It looks like they are not same. Is it same? If you say different is different picture, you tell me what is the answer. If you say it is same, I will ask you why it is same. If it is different, then one has to be correct, one has to be wrong. Which is correct, which is wrong? This is another fact. Things are becoming very complicated. Yes. Any comment from your side? Madams, any comments? You are saying there is something interesting here, right? This is well known from your physics book. This you have learnt now. Some of you might have learnt already, this one. But I am not happy. You are happy, I am not happy. Because both are not same, looks like. My question is, if they are the unique definition, they have to be same, right? Otherwise we cannot accept it. Otherwise you cannot accept it. Best thing is that can you prove their same? Can you prove their same? Is it possible? You don't need to know anything. You know properties of triangle. With the 10 plus 2 trigonometry and physics knowledge, can you prove it? Say. I am giving a lot of hints. With the 10 plus 2 physics and trigonometry knowledge, can you prove their same? Physics definition: summation ui square whole to the power half, summation vi square whole to the power half cos theta. I am writing precisely in terms of norms, right? If you look at your diagram, this is u and this is v. This is position vector u, position vector v, and this is theta, right? This is your third side. You don't need here, okay? You don't need here. Can you find cos theta in terms of the length? Properties of triangle we have done in trigonometry class 2 or class 1, I don't know exactly. Cos theta. What's the relationship between cos theta? If I say this is A, this is B, this is C. C square equals A square plus B square minus 2AB cos theta. Do you remember this formula? Yes. Can you apply this and try to prove both are same? We can assume this belongs to Rn for proving. I am giving that much liberty. You assume everything real. You assume U, V, they both belongs to real n dimension of a real space. Can you prove it? So cos theta will be replaced by that formula, and here you have summation of ui vi. So you have to finally coming up from here, it has to become summation ui vi, and in that case you can say both are same. So your home task, you go home and try to prove it. This is definition and that Felicia's definition. Did you get my question? Yes. If you have any problem, you can ask me here. Where is what the question? I can explain to you again. You understand properties of triangle, right? I think if you understand properties of triangle, you can replace cos theta by the length, and your job is to show this is nothing but summation ui v. How to show? That's your purpose. If you can show, that's it. Physics, mathematics, both are same. The language may be different, but they are talking the same. Right? Conduct here about inner product space. What is called inner product? Okay, fine. So now we'll be talking about the properties of inner product space. We'll now start talking about any questions, any doubts? So what I am saying, UB belongs to C to the power n, complex space, dimension n, n-dimensional vector space with complex quantity, C to the power n. First property, inner product of U plus V W equals inner product of UW plus VW. How to prove it? How to prove it? Left hand side, U plus V W. What should I write? From definition? Try to prove from definition. No need to have any picture. Definition is from definition how to prove it. Next step, summation. I am giving the hint. Summation I equals to 1 to n, then uy plus vi wi. Wow, yes. And then next steps I will know, which is uy wi bar summation I equals to 1 to n vi wi bar, and this is from definition u bar w bar plus v bar. Right? First property is clear. Second property. Inner product alpha u bar v bar is alpha u bar v bar. Of course, very easy to prove. Alpha belongs to numeric field. It could be complex quantity. Alpha belongs to numeric field. It could be complex quantity. Doesn't matter. It could be complex quantity. So alpha, you can say it could be complex. Doesn't matter. If you want, you can prove it. Okay. This proof I will just keep it. Number 3. Inner product UV equals to. Can we write? Question mark. See, for metric space you could write dUV equals to dVu. Okay. Norm space you need two vectors. Norm space you have only one vector. Again, two vectors came in inner product space. Can we write this? Yes or no? Yes. How is it possible? No. Left hand side UV, which is summation ui vi bar. Am I correct? Right hand side summation inner product vu is summation vi ui bar. Are they done? Can we write AB bar equals to BA bar? I will give you the result. A equals to 3 plus 2i, B equals to 5 plus I. AB bar is 3 plus 2i into 5 minus I. Am I correct? And BA bar is 5 plus I, 3 minus 2i. Are they same? I want the answer. Are they same? Yes or no? Yes or no? When it can be same? If I put like this, so the property is so simple thing you forget, but this is the when you forget, bring the example from the school level mathematics. Because as I say always that this mathematics course is based on 10 plus 2. If you have any problem anywhere, you go back to class 2, you get the answer. And here also you got the answer. Okay? So left hand side equals right hand side. So this is now the equality. Next is, so you see that, so our right hand side is this, and if you put a this thing, so you can actually say that this is okay. So this you can actually write as UV bar of this. That's it. UV bar of this. What you have to do that? You have to put double such, because any complex quantity you can write. Right? This is the way you have to prove formally. Okay. So when you write this definition, so you can always put double bar. So when you take this one, it will be summation ui vi bar, which you put double summation ui vi bar is uv. So it is uv bar. Understood? So because any complex quantity we can write a equals to a double bar. Right? You cannot write a equals to a bar, because if a is 3 plus 2i, a bar is 3 minus 2i. 3 plus 2i is not equal to 3 plus minus 2i. But if you put double bar, it will become 3 plus 2i. This is all actually done in your 10 plus 2 algebra. So this is the formal way. So now we can say left hand side equal to right hand side. So basically this 2 bar is very important. Next property, very easy. Number 3, 4. Number 4. Inner product u greater than 0. That is quite obvious. Because I am assuming that u is not equal to 0. I am assuming u not equal to 0. Okay? I am assuming u is not. So if it is u is a null vector, there is a problem. U is not a null vector. So I am taking angle between the two vectors. Angle is what? 0. What is cos 0? 1. So it cannot be 0. Cos 0 is what? This is the way you have to think. So basically you are in advantageous situation because you know both physics and mathematics. Mathematics has tried to do a lot of proof and all those things. You will see your physics side from picture, you get the answer. Then you can prove again. And how to prove it? Mathematically. So it is nothing but summation ui square. Inner product. Summation ui square plus summation ui bar, which is complex conjugate. So it is like the ui square, right? A plus ib into a minus ib is a square plus b square. Okay? And then what actually happened? This is all square quantity, which cannot be negative. So this has to be positive. This from mathematics. So both ways I am actually proving this one. Number 5. Inner product u alpha b bar equals to, can we write? Can we write yes? 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 How many yes are there? Lot of yes. Any no's are there? Any no? How many no's are there? No. So everybody is saying yes? Everybody is saying yes. You are saying no, but okay. Anybody else? Okay, why? Yes. Alpha has to be? Alpha is, I didn't say alpha is complex, no? Yeah. Yes, that's the rule. So since alpha is a complex quantity, this is not valid. The correct is alpha bar complex conjugate. How to prove it? Left hand side, u alpha b bar, which is summation I equals I ui alpha bi whole bar, and AB bar is complex quantity. You know that AB bar is A bar into B bar, right? So alpha B bar will be taken out. So it is summation ui bi bar, which is alpha bar inner product, right? Okay. So we have done all the properties. Next we will be going to some interesting inequality, which is called as Cauchy-Schwarz inequality. Next we are going to some inequality called as Cauchy-Schwarz. But before going to that, all these inner product definitions can be used to prove the property of the norm linear space. Okay, what I am saying that I will repeat once again. Now you know the definition of inner product space, properties of inner product space. My question is, can you prove the properties of non-linear space from the definition of inner product space? For example, one of the properties we have seen, which was complicated, norm of u plus v less than equals to norm of v plus norm of v. Can you prove this from the definition of inner product space? Left hand side, norm of u plus v, which is norm of u. How to write in terms of inner product space? Let's see who can give me the answer. Norm of u, how to write in terms of inner product space? Norm of u is what? Summation of ui square. What is that? What can you write? Inner product space? No. U comma u is one person, please. Yes. U comma u, that's all. Inner product you should say. Less than u, you are greater than u sign. That's all. Inner product u comma u, that's all, or something else? Pardon? No, but how can you write transpose? Don't give any kind of arbitrary thing. How can you write transpose? Did I write any transpose here? Come on. Don't say transpose. It doesn't make any sense. Because it's scalar quantity. Yeah, anybody is giving any answer? Yes, madam? She is saying not inner product u comma u, which is not the correct answer. Square of the what? What is the definition of? See, you are guessing. That's the problem with you guys. This is the definition, right? And what is u comma u? Summation ui bar, which is summation ui square. Right? How to derive this one? Norm of u equals to, is that correct? What to the power? You are saying transpose at all. I don't think mathematics is that complicated way. Mathematics is very simple. I cannot say transpose here because inner product is scalar quantity. There is no question of transpose. Okay? So, how can I write left hand side inner product in terms of inner product? How can I write left hand side norm of u plus v? Norm of u plus, how can I write? U plus v comma u plus v to the power half. Next step. Next step. Next step, yeah, we have done correct. So far everything is correct. Otherwise I will object. Next step is what? Any property you can use from inner product space. See the property number 1. Don't look at the board. You have every answer in your exercise book. You have the answer there. Property number of inner product space. What is that? U plus v comma w. It is u comma w plus v comma w. Okay. So I assume this as w. So this is u comma w plus v comma w whole to the power half. Am I correct? Yes. Yes. Then what is actually happening? You have to replace w by u plus v u plus v whole to the power half. Next step, you can write this as u plus v comma u bar plus u plus v comma v bar whole to the power half. Am I correct? Yes. Again you apply property number 1 under the bar, which is u plus vu. Here it is under bar uv plus vv, and try to prove this formula from inner product space. So I am giving so much of task. First you have to prove to the definition of nonlinear space. Second you have to prove the definition of inner product space and the properties. So these are another home task, and I want to see how we are getting the answer of this. So I'm not clear what I said. So from here I have given the steps. I will not do all problems here because you have to go as home assignments, otherwise you won't learn much. Okay? And I want to see who can submit to me on the Monday this entire stuff. Okay? Okay? Does it make sense? Does it matter what I want? Okay. Next step. Next, actually I'll be talking about. You got the point, right? What I want to prove. So next you have to apply the property number 1 and see how it is done. Okay? I'll be talking next. Cauchy-Schwarz inequality. This is very difficult. You don't know anything, right? But I will tell you that this also you knew from your 10th plus 2 physics. It is quite difficult. I think anybody can give me the answer. What is Cauchy-Schwarz inequality? I guess nobody knows, right? If somebody knows, I really appreciate. But I don't think anybody knows. I will first write, which is mod of that less than equals to norm of u. 2 norm is just like 1 norm. You can write it. 2 norm is like length. This is by default. You can write, you can omit also, but so generally here is nothing but this, but some books write 2 norm. 2 norm or lengths. Okay, why they write 2 norms I will tell you. So basically this is defined as summation of ui square whole to the power half. That's why this 2 is coming. Sometimes what people write, summation ui to the power p 1 by p, which is called as pth norm. So that's the philosophical perspective, which is called as pth norm. Okay, so I am giving you now 1 minute how to prove this from the 10th plus 2 physics. This is the Cauchy-Schwarz inequality. You have to prove it from the property of inner product space. From the inner product space, like mathematician, the proof will be almost like your 1 page in exercise book. But from VC's point of view, these are only two lines. Let's talk about VC's point of view and give me the answer. We have done in 10 plus 2 physics. We have done in 10 plus 2 physics. Let's see how good your physics knowledge is from 10 plus 2.
Sir, UV was over there. So that is U into V into cos theta.
Yeah.
So and cos theta is less than equal to 1.
Wow, excellent. Great. So what he's saying, this is P, this is Q, and this is theta. So it is P dot Q. We have P, we have Q, cos theta. And cos theta is P dot Q divided by P Q, and which is less than equals to 1. So P dot Q is less than equals norm of Q, and that's what this is. So V is goes, so that's what I'm telling. Everything is coming from your physics. It is done, right? 10 plus 2 physics. It is done. So whatever I'm teaching is done in 10 plus 2 physics. But now mathematicians will come in picture and try to prove this one. The Cauchy, that's called Cauchy sword. So mathematicians always give different kind of perspective. So Cauchy and Swartz, they propose this inequality in mathematics, and that can be proved based on the properties of inner product space. So let's look at the proof of Cauchy-Swartz inequality from the properties of inner product space. Let's talk about the Cauchy-Swartz inequality. Let's talk about the Cauchy-Swartz inequality from the inner product space. So let's talk about some vector. Let us assume W equals to U minus alpha V bar. Alpha is scalar quantity. Let us assume W equals to U minus alpha V bar. Okay? I will start from here. And of course, this is the property we have seen. I think property number 3 or 4, right? Property number 4? 4, right? Greater than or equal to 0. So now, we substitute U minus alpha V bar, U minus alpha V bar greater than or equals to 0. Next, what you do? Can we use property number 1? What did you get? So for property number 1, this should not be split, only this should be split. So then what did you get? U bar minus alpha V bar, minus alpha V bar, U bar minus alpha V bar greater than or equal to 0. Am I correct? Yes or no? Next step, we have shown it for the previous example problem. What is the next step? To apply the property number 1. We have done just now, previous problem. What is the next step? What is the next step? Previous problem just now we have done. Pardon? Comma U whole bar, yes. Otherwise you cannot apply the property. So U bar minus alpha V bar, U bar whole bar minus again U bar minus alpha V bar whole bar greater than or equals to 0, and which is next step will be U bar mod minus next step A minus B bar, which is A bar minus B bar. Am I correct? Yes. Same thing I am doing. So this is under this, it will be U bar minus alpha V bar U bar under this, and you can split to A bar minus B bar. So tell me the next step. Tell me the next step. Minus alpha. Alpha belongs to which space? Minus alpha bar. Yes, please. Anybody? Raise the hand and tell me the answer. See, everybody is talking. Yes, please. Alpha bar B comma bar. Yes, next. Can you complete this one? Next. What is that? So here actually one thing I have missed. Yeah, here everything is fine. Yes, tell me alpha. Alpha bar will be there. So okay, if we split apart, you are getting u alpha v bar minus alpha v bar. Then if you split this, what do you get this term? Alpha bar you get here. Alpha, that's what I am saying. Outside alpha. Then next will be, what will be here? What will be here? Alpha square. No, alpha bar. No, alpha will come from here. Alpha bar will become alpha. Alpha will become alpha bar, and then it will become v comma v. Am I correct? Yes or no? Am I correct so far what I have written? Everything is alright? Any doubts? Any doubts here? Any doubts, you can catch me here. So up to this, you try to justify all the properties what you have learned. Next class we will be starting from here. Thanks for your attention.